So this is what we have learned from the previous video, that every time we take a sample, the average of this sample will be distributed randomly around the average of the population. How far it can go from this average? It depends on several things, because we use a student's t-distribution. This is the standard deviation of your average values, which is usually called standard error in statistics. So standard error, it's a standard deviation, but for statistic. We use standard deviation term for values, but in case of statistics, we use a term standard error, okay? And then t tells you how many standard errors you should go from the average. And t depends on two things. It depends on the confidence level. It depends on how big the interval is in percent. For example, 95%. And it depends also on degrees of freedom, right? So this is what we know so far. Now look, we can sort of look at this formula in a certain position. How many things we know and how many things we don't know. Well, we definitely know the average of our sample, right? Every time we take a sample, we can calculate average. And then we know also we can calculate standard deviation and we can calculate the sample size. We know the sample size, right? What we don't know is two things. First of all, we don't know the average of our sample and we don't know the t-value, right? So these two things are unknown. So what it means? It means that if you have two unknowns, it means that if you know one of these two, you can estimate the second one. So you either get a knowledge about t and then you can estimate mu, or you know mu and then you can estimate t. So it's like two sides of the same thing, okay? And this is the main idea of the inferential statistics, that you either know uncertainty, and then with a known uncertainty you can estimate a parameter, or you know a parameter, you pretend that you know a parameter, and then you can estimate the uncertainty. So you can estimate a sort of extremeness of your sample, okay? So let's discuss this in a bit more details, okay? So we have two possibilities for the inference. Possibility one is to calculate a parameter of your population as an interval, which is called a confidence interval. In this case, you need to find t, because you have two unknowns in this equation. You have two unknowns, mu and t. You need to find t if you want to compute mu, right? And t will depend on this uncertainty level, how uncertain you want to be. 95% cases, 99% cases, 99.9% cases. You can calculate t if you know the uncertainty, right? And then you can calculate mu as an interval, which is called a confidence interval. The second possibility is when you pretend that you know mu. Quite often, we will talk about this, quite often you can actually assume what kind of mu you expect from the population. And then you can do the opposite. You can estimate t for a given mu, and then you can estimate a chance how likely you can get a t like this, or for example even larger, if the assumption about mu is the same, is correct. Okay, this way of doing inference is called hypothesis test. So when you know t, when you find t and estimate mu, it's a confidence interval. If you know mu and you estimate t, it's a hypothesis test. But both are based on the same thing. They are based on the theoretical distribution of your statistic. In this case, it's a distribution of average values. Okay. Now let's talk about confidence intervals. Okay. Let me give you some intuition first of all. So you know that t-value, if you would like to get a confidence interval, we need to estimate t-value. T-value depends on two things. It depends on the size of the interval and it depends on the sample size, right? Let me show you a couple of examples. This is a standardized t-distribution, so it means that average is 0, standard deviation is 1. Then you can see that if you take 90% interval, so if you want to have 90% of possible cases here, and sample size is 10, the t-value will be 1.83, okay? Then if you want to increase the interval, so you have 95% here, 95% here, and sample size still 10, you have to take 2.26 standard deviation, standard errors, okay? Then finally, if you want to get 99% cases, for the same sample size, t will be 3.25. So t-value depends on two things. It depends on the sample size and the size of the interval, the uncertainty you would like to calculate your confidence interval with. Okay. Then you can see that since the distribution is the same, these t-values can be estimated using the ICDF function, right? So it's a function that gives you a value for a given uncertainty. For example, this t-value will be ICDF for 0.005 and then n-1 degrees of freedom. And this t-value will be ICDF for 0.995 and n-1 degrees of freedom, right? And the difference between these two values will be is that this one is negative and this one is positive. Okay, so it's just a couple of things about how to find the t-values. You can also find the t-values in a table, it doesn't matter. Okay, so now what's the idea? The idea is following. These three t-values gives you 90% of possible m values, 95% of possible m values, and 99% of possible m values. What it means? It means that if you take this interval, this window, every time you take a sample, you have 90% chance that the average of your sample will be within this interval. If you have this one, again, every time you take a sample, you have 95% chance that your sample statistics, your sample average, will be within this interval around the true population average. Okay. Then finally, in this case, you have 99% cases, 99% chance. Now think, you can do the opposite. So instead of taking the chance for the sample, you can take a chance for the population parameter, right? So if sample is within this interval, it means the opposite. If you make this interval around the sample statistics, the average value for the population will be within this interval, okay? So you can think that if you use this t-value, you have 90% chance to get a sample. So if you make an interval around the statistics of your sample, the true population parameter will be inside. Then you have 95% chance and 99% chance. So that's the meaning of confidence interval. You construct a confidence interval around statistic of your sample, because you don't know parameter of the population, and then you have a certain chance that this particular sample, will have the true population parameter within this interval. Okay, so that's the confidence interval. That's the idea of confidence intervals. So confidence interval is an interval estimate for the population parameter, and you can do it with a certain confidence. This confidence also is called confidence level. For example, 95% confidence interval for average height is 175, 180. What it means? It means that 95% chance to get a sample of, like you, for example, like you have. So this sample contain the true population average within this interval. So you can think that 95% chance that actually the true population average value is within this interval. Okay. And then if you calculate 99% interval, you have 99% chance to get a sample like you, and then it contains the true population parameter inside this interval. Okay. This chance in percent is called confidence level, and this is something you have to decide yourself, and this is something you have to decide before you run all experiments. So this should be decided before all experiments, but otherwise it will be cheating when you actually change the confidence level depending on the results of your experiment. That's important.